Hello and welcome to our final of the 4 series on machine learning. I would recommend that you review the unsupervised and supervised machine learning portions of this series first before we get into this. This is to me the most exciting and interesting. Um, it is also the most up and coming aspect of machine learning. You'll be hearing a lot more about it out there for various reasons, which we'll get into. We'll start with terms and definitions. There are a lot of adjectives and acronyms floating around out there. We'll kind of clean that up so we can set the stage. We'll then look at the motivations. There are many reasons why machine learning should be explainable. We'll then look at some different types, very high level, and then we'll finish with an example. One thing I should mention is that there's a lot of interdependency among some of these topics. So we'll kind of have to jump in and out of different topics and refer back and so forth. It's an unavoidable aspect of explainability, but I think you'll enjoy it and I think it'll make a lot of sense. The explainability of machine learning, or the explainability of artificial intelligence, as it's often referred to, is really an umbrella term. It's very ambiguous. It doesn't adequately cover some of the nuances and the different facets of this rather complicated topic. I have come up with my own 3 buckets, I think, that cover the breadth of the issues pretty well, and I think they hold it pretty well in the more formal data science community. The first is interpretability. Many unsupervised and supervised machine learning algorithms, sometimes called models, are complex, and we have to understand how they're doing what they're doing under the hood so that we can properly establish that the predictions it's making are valid. Explainability has to do with the ability to explain that interpreted model to someone else. Very often a model is a contribution of people from many different backgrounds for the model to be properly developed. So they each have to understand what's going on, that is explainable to them, so their contributions are adequately accommodated in the development of the model. This is also important in compliance, which we'll get to shortly. This last bucket is really more around public policy and how we're affecting the rights of others. Fairness of the algorithm, bias of the algorithm. Often this area is called responsible AI. I would note that data itself can have biased or unfair data in it. Sometimes there's certain algorithms that might process data in a way that results in something that's unfair. And sometimes the person who is the data scientist may not notice things that are unfair. And by unfair and biased, we mean, are we discriminating against somebody for housing or for credit? Oftentimes, algorithms are used to help determine whether someone should, what their bail should be set at, or what criminal sentence they should have, or when they should be released from prison. So we want to make sure that we're in this area and we're affecting the rights of others in this way, that it is fair. This, of course, does turn on interpretability and explainability, so you can see how these all work together. The motivation behind making machine learning explainable is a broad topic, and there are many significant reasons why you'll want to focus on this. And this is one reason why it's becoming such a center focus in machine learning generally. The first has to do with the return on investment. We started out building the model for a reason, and we want to make sure that it's doing just that. There could be times where a model is doing something you don't know. It might be creating harm or damage of some sort, and you want to know that. So being able to interpret the model and explain it is really going to be key for ROI purposes. Compliance regulations also require explainability in certain circumstances. If a person is denied credit, often they're allowed to demand of the person who denied them the credit that they explain how that decision was derived at. Many of you might be familiar with the GDPR, the General Data Protection Regulation in the European Union. Article 22 says that anytime you affect someone's legal rights with automated decision making, it's called, then they have the right to demand an explanation for how that algorithm did what it did. And the GDPR has some rather severe penalties. So there's real motivation here. The next one is really a product liability negligence thing. I teach a class in a master's program of data science and law, and we have an example where a plane is being landed by a predictive model is sort of landing the plane automatically. Well, the model was done incorrectly and the plane crashes. So you can see how lawsuits would ensue, and guess who would be called into the lawsuit? The people who built the algorithm. So understanding how it works, making sure that you know what's going on is key. The last area is ethical considerations, and we really touched on that in the last slide where we're talking about bias and responsible approaches with machine learning. This does consider issues of privacy, uh, making sure that you are adhering to privacy regulations when you are building models, that when you process private data, there are considerations you have to take into account. Also, the security of the data and of the algorithm development process are all key. So these are the motivations. There are others, but this is certainly motivation enough.